This first problem, we want to find the mean of the following numbers. So I'm going to go to my calculator, press my stat button, enter on edit. I'm going to clear out these lists. You may or may not have numbers there. There we go. And in L1, I'm going to put these. So I got 3 inner, 8 inner, 15 inner, 23 inner, 35, 37, 41, and 48. I'm going to double check myself because I input numbers wrong a lot of times. That looks right. Okay. I'm going to exit out, do second mode, and then I'll press my stat and right arrow to calc and choose one of our stats and press enter. It assumes L1 and tells us our answer, the mean, is 26.25. There we go. Now our next problem here, we want to find the median. So I'm going to go back to stat and go to edit. And yet be careful with this, but you can up arrow and highlight L1 and press clear and then press enter and it'll clear the list real fast. Do not highlight L1 and press delete. It'll delete the list out. Okay, 8, 15, 2, 23, 41, 83, 91, 112, 17, and 25. Assuming I typed all the numbers in correctly, I'll exit out. I'll do second mode, press my stat, go to calc, right arrow to calc, and then enter on one of our stats and enter again. Now if we down arrow, our median's on the second page, and you see median is 24. Now in problem 3, we want to find the sample standard deviation. So I'm going to go back and input that. So I'll press stat, enter on edit, and I'll up arrow and highlight L1, press clear, and then press enter. And we got 8, 31, 57, 119, excuse me, 203, and 411. Exit out, do second mode. I'll press my stat, right arrow to calc, choose one of our stats again, and press enter. Now assuming that I typed the numbers incorrectly, which is always kind of iffy, it says find a sample standard deviation, which is SX. So I'm going to round them to, doesn't specify, so I'll say 2 decimal places, 151.01. Now if this was on the final's multiple choice, so you'll see how many decimal places. Number 4. Oh, by the way, if the problem, instead of asking for sample standard deviation, asks for population standard deviation, that's this one right below it. It looks like a little O with a flip. That's sigma x. 137.86 would be our answer. Okay, so I go to stat, go into edit. I'll clear out that list. And got 5, 11, 31, excuse me, 52, 81, 82, 85, and 115. Exit out, second mode. I'll press my stat and right arrow to calc, choose one of our stats, and press enter. Now I want to, sorry, it wants a sample variance, which SX is our sample standard deviation, so we want to square that. Now you can type all that in, so it's 39, where did I get 39 at? My eyes are that bad? Let me try that again. Okay, press stat, choose calc, one var stats, and enter. It's 39. So when I do 39, it changes. Well, that's not good. I'm not going crazy, at least not in that regard. Okay, go to calc, choose one var stats, enter, and let me write this down. Now, if you're good with technology, you can go to vars and access it that way. 39.398 15079. Okay. And it's asking for sample variance, so I want to square that. If it's asking for population variance, I'd square the sigma x. Okay, so I got 39. That's so bizarre, it changes the numbers there. 39.398 15079, and then push my x squared button. And 2 decimal places, our answer would be 1552.21. Now, if you're wondering the quick way to do that, after you've done one var stats, if you go to vars, choose statistics, number 5, and you see SX is the third one, so I choose that. I did 3 but to choose it, and then press x squared and enter. Then that's a very easy way instead of typing in the numbers. But anyway, that's our sample variance. Now our fifth problem here, we want to find the quartiles, Q1 and Q3. Well, let's go enter these numbers in. So press stat, enter on edit, up arrow, and now press clear. Excuse me. 238, so 2, 3, 8, 10, 31, 33, 37, 41, 41, 43, 47, 52, 81, 82, 82, 111, 131, 142, 153, 172, 181. A lot of numbers here. 201, 217, 218, 305, 415, 502. Okay. Assuming I typed in all the numbers correctly, which is always iffy. 2, 3, 4, 5, 6, 7, 8, 9, 27. I put 27 in. So I'll do second mode, exit out. I'll press my stat, right arrow to calc, enter on one var stats, enter again. And then if I keep doing a down arrow, it tells me Q1 is 37 and Q3 is 181. So 37 and 181 would be our answers. Okay. In our sixth problem, we want to find a linear correlation coefficient. We want to find R. Well, let's go enter our data in first. I'll press Stat, enter on Edit. I'm going to up arrow to L1 and press Clear, enter. And I got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I'm going to right arrow over to L2 and put my Y values. So I got 11.3, 13.7, 18. This is probably the hardest part, is actually typing them in correctly. This is the part I have trouble with myself. 18, 23.4, 31, and 52. Okay, so I'm going to exit out, do second mode. Now, you shouldn't have to do what I'm going to show you here. If you've done homework with the calculator, it should already be set up. But you have to have diagnostics on. So we want to go into the catalog. So I'll press second 0. And then I'll do alpha, and this button looks like x and -1. And then alpha, and this button looks like x and -1. That'll very quickly take me down the D's. And I want to choose diagnostics on. There it is. Once you get a little marker next to it, then you press enter twice, and then that's turned it on. Like I say, you shouldn't have to do that, but okay. You just have to do that one time, unless your batteries go dead. So then I'll press my Stat button. I want to choose Calc, and I want to choose Linear Regression, number 4. You can press the number 4 and it does a down arrow and enter for you, or you can down arrow to it and press enter on it. And then press enter again. Now it assumes that x values are in L1, y values are in L2. Okay, so we're wanting the linear correlation coefficient, that's R. So R is going to be 0.9265. 9265. And that's our answer. Now number 7 says the regression line for the given data is given by this formula right here. It says determine the residual of a data point for which x is equal to 5 and y is equal to 50. Now residual is y minus y hat. Let me see if I can find my PowerPoint to go along with that. It's a little piece of the sum of the squared residuals. See, the residual right here is y minus y hat. Okay, well let's see how to find that then. Come over here. There we go. And number 7. So we got y hat is equal to 4.109x plus 27.98. And determine the residual of a data point for which x equals 5 and y is equal to 50. That's our data point right here. So it's just the point we're looking at. So we're looking at x is equal to 5 and y is equal to 50. Now remember, our residual is equal to y minus y hat. Well, y we already know it's 50, but we need to find y hat. Well, to find y hat, what we're going to do is we're going to plug 5 in for x. So we've got 4.109 times 5 plus 27.98. So we got 4.109 times 5 plus 27.98. Enter. That gives us 48.525. 48.525. So our residual is y minus y hat. Y we said is 50 minus y hat, which is 48.525. And that's going to give us 50 minus 48.525. 525. And we get 1.475. 1.475. Residuals your error. 1.475. There we go. Number 8. There we go. Find the equation of the regression line for the given data. Round value is the nearest thousandth. So let's put these numbers in our calculator. So I'll go to Stat, go into Edit. I'm going to up arrow and press Clear, Enter. Left arrow, up arrow, highlight L1, press Clear, Enter. And 259. So 2, Enter, 5, Enter, 9, Enter. 11, Enter. 15, Enter. 19, Enter. 21, Enter. 25 and 28. So 25, Enter, and 28, Enter. And I'll go over to L2, right arrow over to L2, and we'll put in other values. 100.2, 90.1, 89 and 83, so 89, 83, 70.2, 69 and 51, 69, 51, 43, and 42.5. Okay, I'm going to exit out, and we're going to Stat, right arrow to Calc, and I will choose number 4 again, linear regression. Press Enter on it, and then press Enter again. Again, it assumes L1 and L2 for your X and Y values. Okay, so our answer, and it's actually Y hat, you know, a little hat over it, but can't put that very well. So see, Y hat is equal to A, which was negative 2.344 X plus B, which is plus 106.055. And that would be Y hat. So once we plug in our numbers and we do our linear regression function, we just plug in our A and our B. And that gives us our answer. Okay. Number 9. It's given the following data, time and absences. Then we're given some numbers. Says find the equation of the regression line. So let's do that first. We'll go input our numbers again. So I'll go Stat, Enter on Edit, up arrow, press Clear, left arrow, up arrow, press Clear. L1, 60, 65. I'll take my glasses off. That's kind of bothering my ears. Okay, 70, 58, 63, 72, 71. Right arrow over to L2, and I'll put in my absences. So I got 3, 8, 2, 9, 4, 2, 7. 4, 2, 7. Okay, so I'm going to exit out. I'll press my Stat button, right arrow to Calc, choose number 4, linear regression. I was going to do one of our stats. That wouldn't have been right. And that's going to give us our A and B. So Y hat, what is this, problem number 9, I think? 9. Y hat is going to equal to A, which is negative. I'll take these 3 decimal places. 2.15. In theory, you don't want to take it there. You don't want to round it all, but plus 19.123. So again, we took the A and B they gave us here and plug it into the formula up here at the top, and that gives us our least squares regression equation. Okay, let's see what they're asking for. That's the first part. They want to know that, so I guess I better put y hat equals negative 0.215x plus 19.123, comma, and then they say what would be the predicted number of absences, so they want to know what y is if the time was 80. So what they're wanting us to do is to plug in 80 for the x. So let's plug that in our calculator and see what we get. Negative 0.215 times 80 plus 19.123 inner. Then we'll get 1.923. So that's the second part of our answer. 1.923. Okay, let's look at our 10th example here. Now there's going to be 2 different kinds of probability you need to know for the final. One of them is just your basic probability, where you got your or, you got your and, your addition, multiplication, conditional, all those, and then you got your normal. The normal distributions is very easy to identify. It says the word normal, and we'll see that. So number 10 says, given the following spinner, assuming every number has an equal chance of being landed on, find the probability of getting a 2 or 5 or 4 on a spin. 2, 5, or a 4. Well, there's 5 possibilities. So we got 5 down below. And 2 or 5 or 4 are 3 of those possibilities. So our answer would be 3/5. Sometimes I get the question, well, do you want that in fraction or decimal? It's multiple choice. You'll be able to tell. Okay. Number 11. A die is rolled. Find the probability of getting an even number or 3. Well, let's look at a die and see what's on it. A die, we got 1 dot. We got 2 dots, indicating 2. We got 3 dots, 4 dots, 5 dots, and 6 dots. Okay. Die is rolled. Find a probability of getting an even number or 3. Well, there's 6 possibilities. The even ones. This is an even one. This is an even one, and this is an even one. 2, 4, 6. Now 3, that's right here, which means we're looking at getting any of those 4. So we'd have 4, 6, or 2/3. Okay, number 12. Given the following table, find probably getting a man or a junior if a person chose at random. So, probability of a man or a junior. Now, or is addition. So let's look at the man first, and then we'll look at junior. Well, total down here there's 150. So 150 total. And look how many men there are. There's 60 total. So that'd be 60 out of 150. Juniors. Juniors, well, there's still 150 total, and if I look at the total for juniors is 70. Now, when we look at this, we added the man row here, 30, 10, 20. We also added the junior column, 20, 50, 70. So we added this 20 here twice. Any that you add twice, you have to subtract off. So we're going to subtract off 20. That gives us 130 minus 20, 110 over 150. I'm guessing that probably usually in multiple choice they'll put those as decimals, but let's see. 110 divided by 150. Try it again. There. So our probability will be 0.73, well, 3 threes. .7333. Okay, let's look at number 13. Card is drawn from a standard deck of 52 playing cards. Find the probability that the card is a king or a red card. Express probability as a simplified fraction. Okay, so probability of a king or a red card. Again, OR is addition. There's 50, how many cards are there? 52. 52 cards. 4 of them are kings. For the red, there's 52 cards. 26 of them are red. But 2 of the kings we counted here were also red. So we counted them here, and we also counted them here. So we're going to subtract off 2. That gives us 4 plus 26 is 30. Minus 2 is 28. 28 out of 52. And say you stink at fractions. You can use your calculator to simplify it. 28 divided by 52. Math, enter. Gives us 7/13. 7/13. There we go. Okay. Number 14. 2 dice are rolled. Was probably having a total of 5 or 8. Number 14. There's 36 possibilities total. If I start listing them, you know, here's 1, 2. What am I doing? Shh. It's bedtime. It's 8 o'clock. Okay, 1, 1. And you can have 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6. This one can be 2, 3, and so forth. So you can have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Or your first die can be 2. So you can have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6, and so on. And if you listed all of them out, you'd see there's 36 possibilities. There always is. Okay, we're looking at a total of 5. So let's look at the 5. What adds up to 5? Well, 1 and 4 does. 2 and 3. 3 and 2, and 4 and 1. Is that it? I guess that's it, isn't it? Now, 1 on our first die and 4 on our second die is different than 4 on our first die and 1 on our second die. So that's why I listed them separate like that. Okay. Then 8. Let's see, there's 1 and, well, no, it's not 1 and 7. 7 can't be in there. 2 and 6. 3 and 5. 4 and 4. We can also have 5 and 3 and 6 and 2. Assuming I'm not missing any. Okay, there's 36 total possibilities. It's 4 here, it's 5 here, so that's 9 out of 36. They're both divisible by 3, so that gives us 3 out of 12, which gives us 1/4, 0.25. Actually, it wants a fraction, though, I think. Round to the nearest hundredth. Okay, I'm lying to you. 0.25. Okay, let's look at number 15. Let me grab a drink here. Tablet to blow up and bring up another copy. There we go. We're 15. I got 20 white, 10 blue, 15 red, 5 yellow, 2 green. Let's see how many that is total. 20 plus 10 is 30, 45, 52. 30, 45, 50, 52. Okay, a ball is selected from the bag is color noted and then replaced. You then draw a second ball, drawn as color, and then replace the ball. What's probably selecting 2 white. So first one's going to be white, and the second one will be white with replacement. Now, first one's white and second one's white, and is multiplication. So it's 52 total. There's 20 white. I pull one of them out. I'll look at it, say, okay, it's white, and I put it back in. So there's 52 again, and 20 of them are white. So looks like decimals is how we want this one. So 20 divided by 52 times 20 divided by 52. Enter. And 0.1479. .1479. Okay, let's look at number 16. Consider a political discussion group consisting of 10 Democrats. It's always good to write down what you're working with. 10 Democrats, 30 Republicans, and 20 Independents. Total, 60. Okay. Suppose the 3 group members are randomly selected in succession to attend a political convention. Find a probability of selecting 3 Republicans. Now, you're choosing 3 to attend a convention. It wouldn't make any sense for us to pick the same person over and over. So we want 3 separate Republicans. So the first one's going to be Republican, and second one's going to be Republican, and third one's going to be Republican. And is multiplication. There's an implied and there. There's a total of 60, and the first one's a Republican. There's 30 Republicans. So that's 30 out of 60. Okay, now imagine this. We have 60 Republicans there. We took 1 away, so that leaves us 59 in the group. And of those 59, there's only 29 Republicans left because we took 1 of them away already. And then take another 1 away. That leaves us 58 in the group. And of those 58, only 28 Republicans because we already pulled 2 of them away. So we got 30 divided by 60 times 29 over 59 times 28 over 58. Enter. And we get 0.1186. .1186. Okay, number 17. If a person is picked at random, find the probability that they are a woman given they are a junior. So given they are a junior, that means we're only looking at the junior column here. So it means there's 70 total, and of those 70, 50 of them are women. So we'd have 50 over 70, or 5/7. That's a conditional probability. Okay, number 18. 4 cards are drawn from a standard deck of 52 playing cards without replacement. Find the probability that all 4 cards are the same. 4 kings, 4 queens, 4 tens, so forth. This is a commonly missed one. So probability 4 the same. Well, first one's this, and second one, and third one, and fourth one. There's an implied and between all those, so that's multiplication. Now, there's 52 cards total, and we don't specify what it can be. So it means we can pick any of the 52 cards. Now, imagine that what I picked was a 3 card. Well, without replacement means this will now be down to 51. And for this to be true, where they all have to be the same, I have to pick a 3 card here also. Well, I already pulled one of them away here, which means there's only 3 of them left. Then this one will be 50, and then there's only 2 of them left. And then this one will be 49, and there's only 1 of them left. So again, the first one's kind of a seed. It kind of determines which one you're talking about. And I picked an example of like a 3 card. And once we pick a 3 card, let's say it's hearts. Then there's only 51 cards left, and of those 51, 3 of them are 3 cards. Then I pull another one, another 3 card. Then there's only 50 cards left, and 2 of them are 3 cards, and so forth. So this would give us 52 over 52. I really don't need to put in, but just to be complete, 52 divided by 52 times 3 divided by 51 times 2 divided by 58 times 1 divided by 57. What am I doing? 58. Where in the world did that come from? Put 50 there. This would be 49. Some of that new math. I guess I should have looked over what I actually entered in here. Okay, so we got 4.8. And then it says E negative 5. That is scientific notation. That means 4.8 times 10 to the negative 5 power. It means we're going to move our decimal place 5 places to the left. So there's 1 and then 4 zeros. So we got that right there. 0.00 4 zeros 48. Okay. Now the second one says find probably that all 4 cards are aces. So I'm picking out 4 aces. Well, these are all multiplication. There's an implied and in between all of them. Now the first one's an ace. There's 52 cards. There's 4 aces. Now notice this time I don't put 52 up on top. I actually put 4 because that's how many aces we have. Pull one of those aces away. We got 51 cards left. Only 3 of them are aces. Pull another card away, and we only got 50 cards, and 2 of them are aces. And then 49 and 1. So I got 4 over 52 times 3 over 51 times 2 over 50 times 1 over 49. And then press enter. Now I made up these examples, so some of them come up with some bizarre numbers sometimes. 69E negative 6. Okay, it means I move my decimal place 6 places to the left, so I'm going to have 5 zeros, and then 3, 6, 9. And that would be our answer. 0.123, how many is this here? 5. 3, 6, 9. Okay, now these next ones. It says, suppose a brewery has a filling machine that fills 12-ounce bottles of beer. is known that the amount of beer poured by this fill machine, blah, 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 follows a normal distribution. So we're getting into the problems that's talking about normal. Okay, so if we deal with probability, where we got our normal distribution. It says normal in some manner. Okay, we're going to have where we're at finding the probability, and we're going to have 1 whatever. Find a probability that the bottle contains more. We're talking about 1 bottle. So 1 whatever. 1 bottle, 1 student, 1 book, whatever. Now this is going to be just normal CDF. And then we'll do our low, our high, our mean, and our standard deviation. And then there's going to be ones that are many whatevers. We're sampling 20 students and finding the probability that their average age is greater than 20. So this will be normal CDF, our low, our high, our mean, this is mu, and then we take sigma, our standard deviation, divided by the square root of n. And then we'll have normal as an approximation. Spelled that wrong, but oh well. Approximation to the binomial. We'll have normal CDF, our low, our high. Now our mean is now n times p. And the standard deviation is the square root of n times p times 1 minus p. And this is the 0.5 thing. Now those are for our probability. We also have one for the value, which is I and V norm. But we come over here. Suppose a brewery has filling machines that fill... number 19. Okay, has filling machines that fill a 12-ounce bottle of beer. It is known that the amount of beer poured by this filling machine follows a normal distribution with a mean of 12. So telling us mu is 12. And a standard deviation of 0.05. So sigma is 0.05. Find a probability that the bottle contains more than 12.05. Well, here's 12.05. More than is shaded this way. Now we need our low value and our high value. Since it's shaded this way, clear over here is going to be positive infinity, or on our calculator E99. So I'm going to do normal CDF, our low value, which is 12.05, or our high value, which is E99, comma our mean, which is 12, comma our standard deviation, which is 0.05. Let's see what that gives us. So I'll go to second bars into our distributions, choose normal CDF, second one, 12.05, and I made these numbers up, so some may come up with bizarre probabilities, comma, and then second, comma, 99. That gives us our E99, comma, 12, comma, 0.05, enter. So that gives us 0.1587. So 0.1587. Okay, let's look at number 20. And actually, let me start that on a new page. Insert page break. There we go. Guess I should be saving this. Suppose a brewery has filling machines. That fill 12-ounce bottles of beer. It is known that the amount of beer poured by this filling machine follows a normal distribution. There's our key word. With a mean of 12. So mean is 12. And a standard deviation of 0.05. So it'll be 0.05. Find the probability the bottle contains between 12 and 12.2 ounces of beer. 12 and 12.2. Between, I'm shading this way. So our low value would be 12, and our high value would be 12.2. It's just your shaded region. Whatever's over here is your low, whatever's over here is your high. Comma our mean, which is 12, comma our standard deviation, which is 0.05. And let's see what that gives us. So do second vars, choose normal CDF, number 2, 12, comma, 12.2, comma, 12, comma, 0.05. Enter. That comes out perfect. Because when you round it 4 decimal places, 6 causes this to go up, it just becomes 0.5. Okay, so this is going to be 0.5. Number 21. Blah, 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 normal distribution. There's our keyword. That tells us where we're sitting at. Now, specifically, they're saying what chip amount. They're no longer asking us for probability. They're asking us for chip amount. So now it switches to INV norm. So for 21, it says represents a 72nd percentile. So this is what we're trying to find. And percentile refers to the area of the left. So they're telling us 72nd percentile. We're going to put 0.72 here. Now, mean. It says mean is 16.2. And a standard deviation is 0.5. So sigma is 0.5. Now, INV norm is always based upon the area of the left. So the area of the left of this value we're trying to find is going to be 0.72. And then we'll put in our mean, which is 16.2, and our standard deviation, which is 0.5. So I go to second vars, choose INV norm, 0.72, comma, 16.2, comma, 0.5. Enter. And we get 16.49. I take it 2 decimal places. I don't know what this is looking for. Oh, there's hundredth. Yeah, I guess it is. 16 point whatever I said. No memory. 49. Probability I'm going to type in one of these numbers wrong or my eyes are crossed is probably about 100%. So keep that in mind. There's probably at least one wrong answer in here. But I think how I'm working all the problems is very solid. Okay, if the probability of a newborn kitten being female is 0.4, find the probability that in 200 births, 95 or less will be female. Use a normal distribution to approximate the binomial distribution. Okay, so I come up here in my flow chart. Normal as an approximation of binomial means this one over here. We'll come back to that. So let's come down here. Okay, probability of being born is 0.4. So they're telling us P is 0.4. That's little p. Find the probability in 200 births. So N is 200. 95 or less will be female. Okay, 95 or less. Less means I shade to the left. 95 or less, so it includes 95. So I'm going to add 0.5. So this becomes 95.5. I'm shading this way. Now, how do you determine whether to add or subtract 0.5? If your wording includes 95, then your shading has to include 95. So when I was reading this, I was saying 95 or less will be female. That includes 95. So my shading has to include 95. If I had subtracted 0.5 and went to 94.5, my shading would not have included it. Okay, so we're going to do our normal CDF, our low value, which is negative E99, our high value, which will be 95.5, 0.5, comma, and this third one is the n times p, right here. So we got n times p, so we got 200 times 0.4, and then comma, and then the square root of n, which is 200, times p, which is 0.4, times 1 minus p, so 1 minus 0.4. And then we'll plug that in. So do second vars, choose normal CDF, negative second comma 99, so it's my negative E99, comma 95.5, comma 200 times 0.4, comma second x squared 200 times 0.4 times, and now put beginning parentheses, 1 minus 0.4. You don't need closing parentheses at the very end unless you just want to put them, and then enter. And our answer will be 0.9874. So 0.9874. Now, especially with the normal distribution to approximate the binomial, it won't match perfectly to the multiple choice. You just see which ones comes closest to, and that's true throughout the entire test. Because they'll have the by hand version, which is slightly different than technology. Okay. I made these next two up. The mean of grades for college algebra is 73.2 with standard deviation at 5.1. If 20 students are selected, find the probability that the mean grades for which are normally distributed, left something off here, which are normally distributed, is this, and let me change this for college algebra, which are normally distributed. That's a key part. If they don't say that, then you can't just assume you can use normal CDF. Okay, so let's look at 23. And let me erase this, so I'll have a little room. Okay, 23. The mean is 73.2. So mean is 73.2. Standard deviation is 5.1. Says if 20 students are selected, find a probability that the mean grade is greater than 75. Probability. And we're talking about many whatevers. We're talking about 20 students. So we're going to be using this formula right here. Okay, the probability that the mean is greater than 75. Okay, here's 75. Greater than would be shaded this way. So for our normal CDF, we'll do our low value, which is 75, our high value, which is E99, our mean, which is 73.2, and then we take our standard deviation divided by the square root of n. So we got 5.1 divided by a square root of, how many students do we have? 20 students. So divide by the square root of 20. That's the central limit theorem. Okay, so do second vars, choose normal CDF, 75, comma, second, comma, 99, comma, 73.2, comma, 5.1, divided by second x squared for the square root, and then was it 20? Yeah, 20. And then press enter. And that's going to give us 0.0572. 0.0572. 0.0572. Okay, let's look at number 24. Let me erase this one. Let's see, mean is 73.2, so mu is 73.2 again. Sigma is, eyes are jumping around, 5.1. If 30 students are selected, find probability of mean graded between 70 and 73.8. So 70 and 73.8. Between, we're shading this way. So we're going to do normal CDF. Now we're talking about many whatevers because we're talking about 30 students. So come down to here, this is where we're sitting at. We're going to use this formula. So our low value, which is 70, comma, our high value, which is 73.8, and then our mean, which is 73.2, and then our standard deviation, which is 5.1, divided by the square root of n, and here we're talking about 30 students. So divide by the square root of 30. Okay, so do second vars, choose normal CDF, 70, comma, 73.8, comma, 73.2, comma, and then 5.1 divided by second x squared, square root, and 30. Enter. And we get 0.7400. And that's our answer. Okay, let's look at this one. Number 25. Now we're no longer talking about normal distributions. We're getting into the claims. So it says, claim made by a sociologist is that more than 70% of people cheat on their taxes. So more than 70%. And you want to put it in decimal form. To test this claim, 200 people were selected. So n is 200. And it's found 110 cheated on their taxes. So x is 110. And this wants us to find the test statistic. Well, more than. That means greater than. So down here in H1, I'm going to have P is greater than 0.70. And H naught, this would be P is equal to 0.70. I like to teach in my class less than or equal to, but it doesn't make any difference. I like these to be opposites of each other. Okay, to find the test statistic, we're going to, and this is for a proportion, we're going to go into stat, we're left arrow to test, and we want to choose one prop z test. So number 5. Now it'll ask us for P naught, and P naught is always a number off of our claim. So it'll be 0.70. X, which was 110. N, which was 200. Now this prop here, this is what's on our H1, our alternate hypothesis. We got P is greater than. So I want to choose the greater than, which if yours isn't already highlighted, you press your right arrow twice, put your flashing cursor on the greater than, and press enter one time. Down arrow to calculate, and press enter. Now the z equals is our test statistic. So our test statistic for this problem would be negative 4.63. I'll round it 2 decimal places. So negative 4.63. Since it is a multiple choice final exam, I can't ask you to do an entire claim, so I'll just ask you to do a little piece. Okay. Number 26. Determine the critical value for a right-tailed test of a population mean at alpha is equal to 0.05 level significance with 20 degrees of freedom. What are we talking about? Right-tailed. Okay, so we got a right tail, like that. At alpha is equal to 0.05. Now we always split up our alpha into our tails. We only have one tail, so we put the entire 5% there. And I put 95% in there. 20 degrees of freedom, so df is equal to 20. And determine the critical value. Well, we have to look at the t-distribution table. Here's the t-distribution table. I know it's kind of small, so you can use your imagination. Now this says area in right tail. It should just say area in one tail, because sometimes we don't have a right tail. We're looking at a left tail. But the area in one tail is 0.05, so I'm looking in the column that's 0.015. So I'm looking at this column right here. And we're going to go down to degree of freedom of 20. Which is right down here, which is 1.725. Determine the critical value, yeah. So 1.725 is our answer. Now, if we had been dealing with a left tail, like if we had that same setup, but 0.05 was over here, they told us it was left tail, this would still be 1.725. That doesn't change, but if it's on the left side, it becomes negative. That's the only difference when you're using that table. If the critical value is on the left side, it's always negative. If it's on the right side, it's always positive. Okay, 27. Find the standardized test statistic, t, for a sample. This is, we're going to use a t-test for this. Test statistic, you can use your calculator to find it for the proportion and the mean. And so let's write down what we got. 27. N is 18. X bar is 42.1. X bar sample mean. S, which is sample standard deviation, is 3.5. And alpha is equal to 0.05. H naught mu is equal to 39. Now this is the problem. Is when you're using a calculator, it wants a symbol off of H1, off your alternate hypothesis. And if they give you something like this, H naught where mu is equal to, if like the book does, if they always put an equals here, you have no clue what this is. Now we're going to assume that it's actually an equals, which means this is the opposite. If that's equals, this has to be not equals, 39. I think the calculator actually gives you the same answer no matter what symbol you pick on those, but okay, so we come here, we'll go to our stat, go to our tests. It doesn't in the next chapter, but in just the claims it does. Now choose t-test, number 2. And we got data and stats. Data is when you're given raw data, and stats is when you're given summary statistics. Now if your data is selected, like that right there, you want to right arrow over, put your flashing cursor on stats, and press enter one time. Now mu naught, this is a number off of our claim, off of H naught, H1, which is 39. X bar was 42.1. SX, that's our sample standard deviation, 3.5. N, which was 18. It's pretty small N. And the symbol off of our H1. Which was not equal to. So I had my flashing cursor on it, so I pressed enter. And then I'll down arrow to calculate and press enter. The t equals is our test statistic. So for this one, t is equal to 3.76. And that's our answer. 3.76. Okay. Now, number 28. Determine the critical value for a right-tailed test of a population standard deviation with 15 degrees of freedom and alpha is equal to 0.05 level of significance. Number 28. This is supposed to be a chi-square. The picture looks slightly different. Same idea if you drew a bell shape, though. We're dealing with a right-tailed test. And we always put alpha into our tails. So it tells us alpha is 0.005, so that goes there. And this would be 0.995, because all of it has to add up to 1. Now when it says find the critical value, we're trying to find this one right here. And they tell us 15 degrees of freedom, so df is equal to 15. So let's go look this up. This was the t-distribution table. We want to look over in the... how do I go to the next page? There it is. Chi-square. Now chi-square is based upon the area to the right. So the area to the right here will be 0.005. So we want to look in the far right column, where we got 0.005. Now our degree of freedom is 15, so we want to scroll down to 15, and we get 32.801. So 32.801. And that's our answer. That's our critical value. Now, the critical values for chi-square are always positive. So even if it's on the left side, it's still positive. Uh, 29. Compute the standardized test statistic chi-square to test a claim. I may have to look this one up. I'm kind of drawing a blank. Long day. The test statistic, let me try to guess it, then I'm going to look it up just to verify it. I think is n minus 1 times s squared over sigma squared, or sometimes this is referred to as sigma naught squared. Double check myself. This would have been 10.4. Yep, that's right. Oops. Okay, so let's see what we're given. Now to calculate this, we need n, and we need s, or variance, and we need our sigma naught. And again, you can have this squared there if necessary. Okay, so n is 15. They're telling us that. S squared, variance, sample variance, is 24.1, so they're telling us that. So it's 24.1. And the claim is that this right here. Well, this would be sigma sub naught squared. That's population variance. That's 25.1. Okay, so we're going to have 15 minus 1 times s squared. Now that's already squared, so I don't need to square it again. Over this squared, which is 25.1. 15 minus 1 is 14, so let me simplify that a little bit. 14 times 24.1 divided by 25.1. Enter. And we get 13.44. I see the light at the end of the tunnel. We're just about there. One more. And this is kind of the same idea. Same formula. Got our chi-square is equal to n minus 1 times our sample variance divided by sigma naught squared. So number 30. N is 30. I'm not sure why I put two of these on here. S squared is equal to 80.3. And the number off of our claim was 80.1. So we're going to have 30 minus 1 times S squared, 80.3, divided by sigma sub naught squared, which is 80.1. 30 minus 1 is 29, so I'll simplify a little bit. 29 times 80.3 divided by 80.1. And we get 29.07. And hopefully I wrote down all the answers for everything there. And that's our test review.